Hello, Legacy Sabers. Marsh here. This is the final video of Semester 1 review packet. Yes, there are 2 pages left, but I found that these 2 pages probably don't need to be in 2 separate videos. So this is page 4 and page 5 of the review packet. We are still in the solving quadratics unit. So first of all, we had to solve by completing the square. Now remember, how did we solve by completing the square? First, we made sure we were equal to 0. 2, we made sure that the number in front of the x squared was 1 and only 1. If it wasn't, we took care of it. Then we made some room for blank, so we moved c to the other side, and then we filled in blank. Let's complete those steps before we go further. So first thing I notice, everybody's on the same side. No worries there. But x squared has a 2 in the front. Can't have that. So I'm going to divide everybody by that 2 in the front. I'm going to get x squared plus 4x plus 7 is equal to 0. Now, make room for the blank. So I'm going to make some room for the blank. I'm going to kick the 7 to the other side. But if I add blank on the left, probably should add blank on the right. Second thing, we now needed to find our next steps. Find room for blank, or find what blank is, which remember, blank was b divided by 2 and square it. Then we factored the left and we started to solve by square root. B divided by 2 squared, in my case, is 4. So I'm going to put a 4 over here. If I add 4 over here, better add 4 over there. This right-hand side is negative 3. I now need to factor the left. X squared plus 4x plus 4. It is a trinomial. So x times x makes x squared. 2 times 2 makes 4. And I have to add, so x plus 2. That would be super awesome if I could write that a little faster, right? X plus 2 quantity squared. Let's solve for x. So I'm going to square up both sides. Oop, that's a 2. Plus or minus, there's a negative underneath that radical. It looks like we're going to have another I coming to the party. So it's going to be I squared of 3 over there. I'm going to get x alone. So I'm going to subtract the 2, just put it in front of the plus or minus, and I'm going to get that for my answer. How wonderful. Now, we now need to use the quadratic formula. Don't forget your quadratic formula. Remember, it's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a bumpy, right? I know, pop goes the weasel. I should have been a singer. First of all, let's double check. Are we equal to 0? Yes. Always want to be equal to 0. Now, we're going to determine a, b, and c. Those are just normal numbers, not the w squared. W squared is the guy that is your a. He's paired. So it's 2 for my a, b is 3, c is negative 12. Now it's just literally substitution. Negative b, opposite b, so that's negative 3, plus or minus my b squared, so that's negative 3 squared, minus 4 times my a times my c, all over 2 times my a. Okay, let's figure out my discriminant value. This is 9. Negative 4 times 2 is negative 8. Negative 8 times negative 12 is 96. That's an odd number, right? So technically I have 9 plus 96 underneath that radical. 9 plus 96 is 105. Does 105 break down? 105 divided by 4? No. 9, 25. I don't think it breaks down at all. So this is my answer. Right there. Negative 3 plus or minus the square root of 105 all over 4. And the final unit of semester 1 was graphing quadratics. There were 3 different versions: standard form, Vertex, and Intercept. First, let's talk standard form. To find the middle of your table, which in this case for some reason I gave you 6. I don't know why. I just really like 6 spots in a table. To find the middle of your table, you needed to use a really cute little formula. It was the beginning of the quadratic formula. Negative b over 2a. A, B, C. So negative 4 divided by 2 times A, which was 2. So in this case, our middle is negative 2. Then we're going to put some groupies around our negative 2. Oh, hold on. Negative 4? Oh, Marsh. Too much math. It's negative 1. Silly, silly. Thanks for telling me. So I got negative 2, negative 3, 0, and 1. I'm now just going to substitute these into the problem. So plugging in a negative 3, I get 9 times 2, which is 18. I'm going to do some scratch work here. Minus 12 minus 3. Well, 6 minus 3, that's 3. So that means 1 is also 3. I'm going to plug in 0. That looks a lot easier. It's negative 3, right? Now let's plug in a negative 1. 2 times, well, negative 1 squared is 1, so that'll be 2. Minus 4 minus 3. So 2 minus 4 is negative 2 minus 3. That's negative 5. Let's graph those dots. So negative 3, 3, negative 2, negative 3. That's a deep drop. And then 1, negative 5 right there. Whoop. There we go. And then 0, negative 3, and 1, 3. Connect my dots. Make sure it's nice and rounded down there so it looks like a U. There we go. Concavity, it is up like a cup. Bounded, it is bounded below, right? My vertex is located at negative 1, negative 5. It's the turnaround point down there. Axis of symmetry is where you can perfectly fold this dude in half. This guy has a axis of symmetry right down the middle. It is at x equals, the equation of it is as x equals negative 1. It's an extrema. It has an absolute min in this case. And it is located at negative 1, negative 5. End behavior. Remember, there was a little saying that we said, as x goes to plus or minus infinity, we wrote it at twice because both arms go to the same thing. Remember, end behavior is asking, what do the arms do? Are they going to positive infinity or are the arms going to negative infinity? Are they pointing down? Well, in this case, both arms are pointing up. So I'm going to say that the y's are positive infinity. So on the left of the graph is pointing up, and on the right of the graph is pointing up. My x-intercepts, to find x-intercepts, we set equal to 0, and we have to solve. Gross. I don't think that factors. Let's use the quadratic formula, shall we? So negative 4 plus or minus the square root of b squared minus 4 times my a times my c, all divided by 2a. Okay. Oh, I'm going to run out of room very, very easily. Okay, underneath that radical, I have 16 plus 24. It looks like I get a 40 under there, right? 16 plus 24, that's 40. Divided by 4. A square root of 40 is the square root of 4, and the square root of 10. This is a 2. So I get negative 4 plus or minus 2 square roots of 10 all over 4. Simplified just a little bit more because everybody has a 2, right? Except the 10. Can't simplify him. He's under a radical. That is the x values of my x-intercepts. I'm going to write them in ordered pair form. So negative 2 plus or minus the square root of 10 all over 2 comma 0 are my x-intercepts, not the y-intercepts. We haven't found that yet. That's all x-intercept work. Y-intercept, you're going to substitute 0 for your x. I'm going to get negative 3, 0 comma negative 3. And you're like, Marsh, it was in the table. But what if it's not? We want to be able to find it next time. Domain, remember that is how far left does the graph go? How far right does the graph go? In our case, negative infinity to positive infinity. My range, how far down, how far up? I go to negative 5, and I touch to negative 5. That's why it's bracket. Infinities always get parentheses, though. Increasing interval, where does it look like the graph from left to right is going up? That would start, it looks like, at negative 1. There we go. And I go forever up to positive infinity. So forever to the right, I'm going up. And then I start at negative infinity on the left of my graph. going down, and I stop going down at -1. Let's continue on to vertex form. Vertex form, again, is kind of like absolute value graphs in which we had to have a parent table. So I'm going to figure out my parent table. Well, this guy, x squared would be the parent, right? And we can plug anything into an x squared. So -2 squared gives me 4. -1 squared is 1. And then those numbers, right? Same thing happened here. So this is a reflection. So I'm going to change the signs on everybody. And then I'm going to multiply by the vertical compression, which is multiplying by 1/2. I'm going to move to the left 2. I'm going to add 6 because I'm going to go up as well. So let's figure out my new table. Let's do some math. -4, -3, -2, -1, 0. Ooh, -4 times 1/2 is -2 plus 6, that's 4. -1 times 1/2 is -1/2. That's 5.5. 6, and then I'm going to just copy my table. Let's do a graph here. -4, 1, 2, 3, 4, 1, 2, 3, 4. -3, 5.5. There we go. Oh. -2, 6. -1. And that guy. Let's connect some dots. There we go. Okay. Concavity. Down like a frown this time. Bounded above, it looks like this time. We have a vertex of, ooh, what is this? Ooh, -2, 6, middle of my graph. Axis of symmetry, x equals, because it's crossing through the x-axis, looks like at -2. I have an absolute maximum this time for my extrema. Whew, so good. And behavior, I'm going to say, as x goes to plus or minus infinity, what are the arms doing on the left and the right? Well, the arms on the left and the right are pointing down. So I'm going to say that the y's go to -infinity. X-intercepts, again, set equal to 0. Let's do some solving. Okay, subtract 6. Divide by 1/2, also multiply by -2. Okay, positive 12 there. Square root both sides. Square root of 12 is the square root of 4 and the square root of 3, or 2 square roots of 3. So I'm going to get plus or minus 2 square roots of 3 is equal to x plus 2. Or in this case, x equals -2 plus or minus 2 square roots of 3. Let's write those in ordered pair form. -2 plus or minus 2 square roots of 3, comma 0 for my x-intercepts. Are they disgusting? Yes, but they're answers nonetheless. Let's plug in a 0 for the y-intercept. Now you're probably thinking, Marsh, it's on the table. But what if it's not? So I'm going to actually do some math here. I know, it's on the table. I know. But we're just going to do some math. So -1/2, 2 squared is 4, right? Plus 6. This is -2 plus 6. That's -4. So 0, -4. That was me making sure that my graph wasn't wrong. Don't need a mistake. Domain, it looks like -infinity to infinity. Range, ooh, he goes forever down. So that means he starts at -infinity, but he stopped at 6. So bracket on that 6. Increasing, he starts increasing to the left, on the left. So -infinity. He stopped decreasing though on the x value, so -2. And then he starts decreasing at -2 and goes forever to the right. So I will say positive infinity. And the very last problem of the review packet is intercept form. Remember, how to start intercept form is you had to find the x-intercepts. Set both pieces equal to 0. Well, in this case, I'm going to have an intercept of 3, 0, right? So that would be, that one. And -1, 0. So I'm going to put those in our table. My vertex has to be in the middle because that's how a parabola works, right? We have symmetry. So I'm going to graph 3, 0. I'm going to graph negative 1, 0. I'm going to figure out the middle. Well, it looks like it's at negative or positive 1, right? Positive 1. How do I get the y? Substitute, right? Let's do some substitution. Let's see what happens when I plug 1 in to that problem. Negative 2 plus 2, 4, looks like. So 1, 4, 1, 2, 3, 4. I'm going to connect the dots. Last round of 20 questions. Concavity, definitely down. Definitely bounded above, though, because I can draw a line above this graph, right? Vertex, 1, 4. That's the turnaround point. Axis of symmetry, it's cutting straight through the x-axis at 1. So x equals 1. That's the line, the equation of the line. Extrema, another absolute maximum at 1, 4. And behavior, as x goes to plus or minus infinity, y is going to, we are pointing down, so we're going to go to negative infinity. Y-intercept, remember, plug 0 in. Oh, this one didn't turn out perfect. Oh, I'm actually going to have to find it. So y equals negative 0 minus 3, 0 plus 1. So that's negative 3, positive 1. Looks like a positive 3 is my intercept, which could be. So I'm going to do 0, 3. I'm going to write it as an ordered pair. Domain, still negative infinity, infinity. Every single graph you've ever graphed is that, except the piecewise. Range, we started at negative infinity, stopped at 4. Increasing, I went forever to the left, started up, going up, stopped going up at 1, but I started going down at 1, and I continued forever to the right, going down. And that is the end of the review videos for the semester 1 final. I hope that you have found these 4 videos instructive and helpful, and I will hope to see you later, Sabers.